Now I'm going to talk to you about different types of data. Discrete data and continuous data. Okay? So let's start with discrete data. Okay? When you look at a graph, you know whether or not that data being presented to you is discrete or continuous if whether or not there are meaningful values between the points on my graph. Okay, so I'll say that again. You know whether or not it's discrete or continuous if there's meaningful values between the points on a graph. So let me give you an example. We've got a graph here showing how much money you fundraise by selling chocolate bars. Let's say you're trying to sell chocolate bars to go to Florida for whatever reason. Money fundraised by selling chocolate bars. Okay, so this shows a relationship between what two things? The amount of money you make and number of bars sold. So you sell 0 bars, you make $0. That's the way the world works. You sell 1 bar, you make how many dollars? $5.
These are expensive.
2 bars, $10. It's a fundraiser. Get over it. Okay?
I would buy it. I understand why you had so many left over.
$5 make $25. How much does each bar cost?
$5.
$5. Okay. Question: is this discrete data or continuous data?
Continuous. Right?
You sure?
It's discrete.
I could put a dot right here and say I sold half a bar of chocolate and made $2.50.
That'd be discrete, right?
Who would do that? Or I sold a tenth of a bar of chocolate and I made 50 cents. Is that reasonable? Is that meaningful?
No.
No, that's dumb. Okay? Nobody's going to buy a tenth of a chocolate bar. Okay? So this is discrete data. And with discrete data, you never connect the dots. Because the moment you connect the dots, you're communicating that there's meaningful data in between those dots. You're communicating that there's, a tenth of a chocolate bar that you could buy, or half a chocolate bar that you could buy, and that doesn't make any sense. Right? So don't connect the dots in discrete data. Just leave them as they are. Good? That's discrete.
That makes sense.
Turn the page.
This time we keep
Okay, this time we have a different graph going on. What is this relation? What is the relation being shown in this graph? How far John is away from home and how long he's been running for. So he goes for maybe a 3-hour run.
That's a long run.
Okay. The first 30 minutes, he's gone 4 kilometers. The first hour, he's gone about 7. The first hour and a half, he makes his maximum distance, which is about, how far? 15 kilometers. What does he do at this point? Turns around, so he's at 8 here, that's at 210 minutes. Not, 210? No. 120 minutes, there we go. 150 minutes, he's about 5 kilometers away from home, and then at the end of 3 hours, he's at 0.
Oh, I bet you regrets
Marathon? Sure.
30 kilometers.
Hey, piece of cake. Why not? Yeah. Good job, John. In 3 hours, he's an Olympian. There we go.
That's like running from moment.
Hey, I thought it made sense when I was making it. Back off. Okay. Now, I connected the lines. Kind of spoiled the surprise a little bit. But does it make sense to call this, or to communicate that there's meaningful data between the lines?
Yeah.
Like, could I run up to John 10 minutes into his run, which would be about here, and be like, hey, John, how far have you gone?
Yeah.
Yeah. He'd be like, yeah, I've almost made it, I've just passed 1 kilometer. Thanks, random guy, for asking. Gonna continue with my run now. Right? It makes sense. Right? There's meaningful data between the points. So to communicate that, we connect the dots. The way I like to think about continuous is it's one nice, solid line all the way through. Okay? If there's any breaks in that line, then it's not continuous. Okay? So a continuous set of data communicates that there's meaningful values in between the dots on your graph. You get the difference?
Yeah.
Okay, so now let's talk about Jorge.
Who names a frog Jorge?
Actually, a pretty cool name.
Okay?
Yeah.
Here's our data. Here's our graph for Jorge. Continuous or discrete? We didn't connect them. I didn't tell you to, but think about it.
Oh.
Continuous or discrete?
Discrete. Discrete.
Has to be discrete. They're not connected.
Some say discrete. I didn't connect them. We could have, though.
Because you can't have like a half a jump, right?
But you could have jumped in the air.
What if he like jumps and then you slap him down because you're mean like that? You're like, no, you can't win.
And then you pick up his riddled body and stitch it to a stop sign? Yeah.
Or put him 3 feet under.
Does it make sense? When they measure the distances of the frog, do they measure it every time the frog lands after he completes a jump, or do they measure it like halfway through his jump or like 3/4 of the way through his jump?
Only do it after
Has
you
to be
land.
when he
That'd be kind of impossible, right? You're like, freeze time! Frog's like, and then you measure his distance. No, not reasonable. Okay, so this is what kind of data? Discrete. Okay, this is a discrete graph.
Yeah, it is.
Or a discrete relation. All right. So we've learned that Jorge is a linear, discrete relation. Linear because it's in a straight line. Discrete because you don't connect the dots because it doesn't make any sense. Good.